Hello. My name is Soundb0ard, and today, helped out with Tolly the cat, I'm going to talk about software I've been working on for the past 5 years called Soundb0ard. I was changing job. I was moving into a position where I was going to be working with C and C++, which I didn't know very well, so I was wanting a project with which I could teach myself. I was quite well aware of other live coding, the live coding community, and in particular tidal cycles. So that was my inspiration. I thought I would try and make a live coding environment of my own. I started from the most basics, just trying to create sine waves, and the idea I came up with was a kind of REPL interface with which to interact, create a sound, and you could sort of manipulate it from a command line such as this, which is kind of based after a Unix shell. Something, for years I worked as a sysadmin, and so for years that was my way. My main interface with computers was logging in remotely and working via a shell such as this. So there are a few commands which are based around that. Let's see help first. See what we've got. So we have PS, show program status. Anyone who's used a bash shell or a Unix would understand that as well. It shows you all the programs running or the program status. Here it gives you a logo type thing, some key information, the volume, BPM. We have some data here which all relates to Ableton Link. I used that as a sort of timing library, which means you can jam with anyone playing with Ableton Live or another copy of Soundb0ard here. Some other information which we'll get to a bit more later. The key of C. Help. ls list sample directory. Again, another Unix command. Ls is like list it stands for. Here it shows you my sample directory, so we can ls literally under the program file. I have a directory called WAVs, and underneath that you can drop any you can create any folders, drop samples into them. Let's have a look at the kicks folder. All these kicks. We can preview it using the play command. Play garage kicks. What's this guy? There we go. Oh, that's a nice one. Anyway, help. So yes, we have command line REPL here, named after Unix shell. We can walk through these commands here, but just to kind of get started, the main concepts you need are you get variables, and we can create music making variables. There are a couple of synths. One is an FM frequency modulation synthesizer, which is based around the architecture of a DX100. There is a subtractive synthesis engine, which is based around the architecture of a Mini Moog. Both of them I got in a book by Will Perkle, designing software synthesizer plugins in C++. I spent about a year implementing all of the different designs in that and learning how to build my own synthesizers. Let's create one of them. I'll show you on the help again here. We've skipped a few lines here which we can come back to. This is let dx100 equals fm. The fm command is creating a new synthesizer, and I'm assigning that to a variable called the dx100. This one, let mo equals moog. We're creating a moog synthesizer and assigning that to something called mo, a variable called mo. So here we go. Info mo gives us a bit more. This is if you were looking at a real panel of a synthesizer or a software synth. Top part all in yellow is all this voice information, a voice preset with 3 square waves. You can see the 3 oscillators that it refers to, and they're all square waves. The first, this is more sort of synthesizer design. Since the 2 oscillators here are your main oscillators, you can sort of slightly detune them for a sort of wider sound, but they give the main part of the voice. Oscillator 3 is square noise. You can give it some grit. And oscillator 4, actually say that the wrong way around. Oscillator 3 is actually usually is 1 octave below what the others are, so it just gives it a bit more of a weight. And oscillator 4 is noise, which can add a bit of grit and texture to it. How do you operate these? Let's say note on, say mo. 41. This is MIDI numbers. I'll give you a guide to them in a second also. But this is a F. I think it's an F3 we're going to play on this Moog synthesizer. There we are. We can play it for longer time. Let's do a whole. We can do a shorter. We can turn down the velocity of it. It's default to 128, the loudest. We could do, well, let's hear it as it is. We turn it down. So you can play with sort of velocity, duration, sort of standard MIDI things. So yes, we can do note on the Minimoog. I'll just get rid of that for the moment. Cool. Okay. Let's see. What about the? Let's create a kick drum here as well. See, I was using my recursive Control-R sort of bashism that I sort of implemented in my shell. So this is a command from my history where it's basically creating a sample. I've given it that path for one of the ones we were listening to, and I'm assigning it to the BD sample. So now do PS. I can see I've got a couple of variables. I have a bass drum, well BD, which is a sampler. Gabor kick sampled. Took a snip from, Gabor. Try to think of the first name there. Come back to that. Mo is my Moog. You can do note on with the drum BD. However, it's not pitched, so this is just note on or off for a sample. It doesn't make sense, but it could make sense, but I haven't implemented that yet. So we'll just say 1, and that just is on any positive number would work here. We can also say, so yeah, these would all work. 0 shouldn't. Oh, maybe it does. Yeah, I guess just note on works. So we have two things. We have bass drum, and well, what can we do with them? Let's see, help again. So we can do note on. We can also do note on at, and what that does is put a delay in MIDI ticks. Let me actually. So let's see here. We have. Here's two information things which are useful. Midi Info gives you just a guide to MIDI notes. C3 is MIDI note in a 60, and all the sort of intervals go up by 1, so 60, 61, 62 for C, C sharp, D, etc. You can subtract or add 12 to go up or down an octave. These are just sort of standard, so you could we can do note on, Mo, do 60. I'll keep that duration shorter actually. Equal 50. So we could do 62, etc. There is actually a shortcut, notes in key, and what that is, so PS, we can see we're in the key of C. So notes in key, this is a C. C sharp would be 1, D is 2, so it's basically the scale. Notes in key is a scale in this key. If we play that, it's actually very low at the moment, so that would let's see what I'm talking about. I have another shortcut, play array, which you can give synthesizer and an array of numbers to play, which it will space out over your bar. We can do notes in key, and this will be very low because of these numbers, but let's hear it first. In fact, yeah, should be okay. So there is a scale, but it's very low. How can we take them up? So as I said, this is a programming language. It has an implementation of map. So we can do map, and this is a standard computing function. You give it an array, or a sequence, notes in key, and you give it a function. This function is going to return what the map function will take the function and it applies it to every value in your sequence and gives you back a new sequence where each value has been through the function. So for this one, I'm going to add 12, which is 1 octave, but let's take it up 3 octaves. So what we're going to get back here is the same scale, but with basically with 36 added to each of the numbers, which in MIDI notes that's like a C3, a D3. Sounds much more interesting than that kind of farty noise. What we can do here is apply this, and it should be much more. There we are. So same thing, play array. you can see here there are 7 values for the scale. So when you give it to play array, it has those 7 values. Let's see another function here. Timing info gives us lots of information, which is more of a debugging information, but one thing which is quite important, the loop length in ticks and MIDI ticks is 3840. That becomes quite useful for programming because basically that's the length of a loop. If I want to play something every 16th, I would play it at using the note on at mo 61 again. 0 is now 3840. Actually, we can even do 3840 here, and we'll wait a whole loop before this comes on because it's playing at 3840 MIDI ticks in the future. So what's quite useful for, like, say 16th, if you want something, would be to have 3840 becomes 240. I use this so often, I just assign that to a variable. So there's pp, which is 240. Okay. We have arrays. We have scales. So I thought I was being funny. Use cliches. You can type in strategy, which will basically give you a random Brian Eno oblique strategy. Kind of fun. And also sometimes when you type in help, it will just randomly just give you a strategy. Only a part, not the whole. These can be quite useful for when you're looking for inspiration. What else do we have here? Notes and key, play array. So we've done that. Okay, let's get some rhythm. There's something called Bjorklund rhythms, which is very close, mathematically they're very close to the Euclidean way of finding the lowest common denominator. So quite often it's called Euclid's rhythm, or Euclidean rhythms. There's paper around for this, and it's used very often musically. It gives you these kind of world rhythms, like there's kind of like salsa or rumba, like the. So the common ones are, the way this works, my function implementation. So if I say 3/8, it means it's going to give me back a sequence of 8, and it's going to space hits evenly amongst them. And turns out this is actually a common rhythm. Another common one is this 5/8, and you get these. Let's try the drum machine, the drum playing these. So play array, we'll give it the kick drum, the BD, and let's try the Bjork 3/8, and try the 5/8. So you can see, start getting all these different functions. You can do melodies, you can do rhythms, and it gets kind of interesting. So we've got rhythms here. We have the notes and key. We know what's in the current key. So it turns out I combine these together and create a function called riff. Where it gets a sequence valid notes, gets notes in key. It creates a random rhythm using Bjork, and it does a random 9 plus 2, so it's going to give you some value between 2 and 11 over 16. So it gives a random. Let's show a demonstration of what this gives us back. Ooh. So there we are, we get a kind of random rhythm comes back here of 16 hits with interesting. And so what my riff does, gets a valid notes, gets a beat, walks through the length is 16, your rhythm, and if you get a 1 in there, we take a random valid note and stick that in. So let me show you riff, and you get random riff. It's a sequence of numbers. Let's do play array or synth again, and riff. Let's see what that does. And let's see. So cool, we can do that. We have rhythms. Now, how do you actually make music? Because you don't really want to be typing all this in like that. You want a kind of loop to continue. How do you get it to loop? To do that, you can assign it to these processes. You can see a P0 process here called counter. I just put this in a startup file. all it does is increment a variable called count, which goes up at the beginning of every bar, or loop if you're being pedantic, it's not dependent. So this can be useful. You can do things. You can now do modulo the count if you want it to happen every second bar, every third bar, etc. So the processes get evaluated once per loop. So we can do, let's see, we were doing play array. We'll do this guy. So that's the bass drum. Let's assign this to the first process, and this should just keep going. I think that was a bug there. I think it played it once and it's assigned it to this variable for continuing to do that. And we could do, let's store our riff, and we do play array, do our moog and the riff. Now let's assign that to P2. Actually, I can just P2. Now it's a bit repetitive. I've got this function over, which will play over 2 bars. Now there is actually a bug in this, because this is getting called every function, even though it's actually spacing over 2, which gives an interesting effect. So every there's already going to be one in play when it starts the next one off. But you can do things here. We could change the riff. We could actually reassign, create a new version. Still, this could be kind of repetitive. There's only so much you can do there. Let's close these guys down. So, to make it more interesting, you can actually, it gets a bit hard programming just from the command line there. So I came up with a way of doing what we call in this vids. So the new file I've created .sb under this particular sb tracks directory. I'm going to monitor that file, and anytime I save this file, it's going to reload that. So in here, we talk about process. Something else I come up with here is a there's a shortcut for creating functions, but we want a different shortcut. Blagen. Let me see if you can still see. I'm going to move my video over here for the moment. Okay, so we have a generator, and these generators work kind of like processing on Arduino. There's 2 key functions. You get a setup function, which sets up variables you can store over the lifetime, and we have a run, which is called once per loop. And the idea for these generators is you can assign them to the process slots, and they will get called once, and the setup you can store state. Okay, so we'll call our riff here, and here we will do play array mo rf. So this should happen once every. Let's just try it first. That works. Let's assign that to P1. And again, that's fast. Actually, over. And we have that same bug again. However, if we do count modulo to 0, this means it will only happen on every second turn, which matches that with. Every time you save it, it reloads, so that RF actually keeps getting reloaded. We can actually just use the 1 in our global variables, which is that. Let's change it. Okay, and something else here, so we could do every 4 bars we want a new riff. Let's do something similar with the drums. B1 equals Bjork 3/8. Oh, 1, there we are. Let's kick the drums off. And B1 a second. Starting to, let's see, maybe we don't want it each time, so if module 4 is under 2, alright, under 3. Oh yeah, so that should get 3 out of 4. Okay, so that gives us somewhat of an idea for the moment how you can use code here. I think that will do for the first video. How much have we recorded so far? 21 minutes. Okay, that's a decent introduction. You want to say goodbye to the people out there? Goodbye, people. Goodbye. Alright, see you next time. Thanks.